Let us now study about chain reactions. And to study chain reaction, the very first thing we need to understand how the energy released is utilized in a nuclear reaction. Here we can write in a fission, total energy released, which is the Q value of a fission reaction, is distributed in following forms. You must understand all these forms, how the energy release is distributed. The very first is kinetic energy of the fragments. The fragments which are produced after disintegration of excited nuclei in a fission reaction is approximately 80 to 85%. The total energy which is released as Q value, almost about 80 to 85% is taken up by the fragments in form of kinetic energy. The second one is kinetic energy of emitted neutrons. As neutronic mass is very small, this is approximately only 3 to 5% of the total energy release. The third one is in a reaction we have not right now studied, but in parallel there are gamma rays emission also from the excited nuclei, which contain approximately 2 to 4% of the released energy. And the excited fragments, when the fragments are produced after disintegration at such a high kinetic energy, these fragments are also in excited form. So these also absorb some energy for their excitation. So we can write some energy is taken up in form of excitation of fragment nuclei, which is approximately 8 to 10%, quite significant. And these excited nuclei as contain very small energy, which is approximately 8 to 10% of the total energy. These further do not disintegrate into various nuclei, but we can write here this energy is emitted as beta particles, which we'll study in later sections of this topic. Beta particles or gamma rays by these fragment nuclei after fission. How this phenomena of beta emission takes place we'll study in some nuclear reactions in later part of this topic. But right now we'll just take care the whole energy is distributed in these four major forms. And here one more thing we can write, that in a fission, if initial amount of nuclei are taken properly, there are some minimum number of nuclei if we consider, then it is possible that emitted neutrons which are produced in the fission further continue fission in the available amount, and it can start a self-sustained fission reaction continuously. And this self-sustained fission reaction which continuously be carried over by the neutron produced, this we call chain reaction. This chain reaction sometime may become uncontrollable also, because of continuously the neutrons produced are further producing fission, then the quantity of energy release, quantity of number of fissions per unit time will drastically increase, because each reaction produces 2.5 to 3 neutrons. So one reaction will lead to 3 more reactions, then 3 will lead to 9 and so on. So it will multiply a lot, and when the reaction becomes uncontrolled, it may become extremely hazardous for society also. That's why these reactions are carried out in controlled environment and nuclear reactors for production of a huge amount of energy. As just now we have discussed about chain reaction, that whenever neutron produced in a fission reaction induces other fissions, then continuously the reaction becomes explosive, because due to one fission, if there are 3 neutrons, then the 3 neutrons will induce 3 more reactions, and then 9 and 27 and so on. Continuously the reaction will take an explosive form. Here you can see in this realistic situation, we explain how chain reaction occurs if there is a single nuclide, as if there is a single nuclide on which a neutron is fired. This nuclide becomes unstable and splits into 2 or more fragments and releases 3 neutrons, which further in the sample of a nuclide induces reaction in 3 more, and then these 3 more will further induce reaction in 9 more, and you can see continuously the energy released in every reaction is being added up, and at every step the total amount of energy released is increasing in geometric progression. So such reactions may become so hazardous and may result in a very big explosion if these are not controlled.